Assalamu alaikum and hello to everyone. Today we will be talking about homogeneous and non-homogeneous differential equation. Now to solve homogeneous and non-homogeneous differential equation, it consists of two parts. To have a fully described differential equation, you need to solve two parts, that are complementary function and particulate function. Now how do they work? It actually works like this. Yes, in the above you could see a differential equation which I have placed over there. It states a d1 plus b d2 plus c d3 is equals to fx. Now on the left hand side it's a differential equation and it's equals to fx. Now but to solve the complementary function, that is yc, which you could see below, that I have written for a fully described differential equation, you need to solve two parts, that is complementary function and particular function. Now we are actually talking about complementary function over here, so this video is actually about complementary functions, so we would not consider particular functions over here. Now complementary functions, to solve a complementary function, you do not take the whole equation is equals to function of x, but rather than function of x, you replace it with a 0, which actually becomes an auxiliary equation, which I have written over here. It becomes something like this. Yes, auxiliary equation. Over here we have a, we have d. A is a coefficient, where d is the derivatives, where with the reducing power, and over here you could see I have equaled it to 0. Now 0 for 0, it is necessary because of for complementary functions. Yes, sorry for my English, but yes, it is a bit shady. Now let d is equals to m1 m2 mn. Now what are these m1 m2 and mn? Well, these are just the representation of the derivatives above. Now for example, m1 is the derivative 1, m2 is the derivative 2, m3 is the derivative 3, not actually first, second, or first order, second order, third order, but in sense of its position, that is a0 dn plus a1 dn minus 1. Now dn minus 1 would have been over here is considered m2. Now okay, now we have said over here that m1 m2 mn, which would be the roots of auxiliary equation. Now to solve the roots, I believe you know how to solve the roots. We actually take a differential equation, we solve it for its roots, and then we have, for a quadratic equation, we have two roots, and then with increasing power the roots increase. So over here let us consider that let us now see how many cases could be there for solving a complementary function. Now complementary function consists of about three cases. Now what are they? Well, they are actually these three cases. Case number 1, if the roots of auxiliary equation are real and distinct, let's say d is equals to m1 m2 comma 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 mn, that is, it states the roots of differential equation d. Now for that, if the roots are real and distinct, it's actually pretty easy. You actually write yc, that is complementary function of the differential equation, is equals to c1 e raised to the power m1x, where c1 is a representation of the complementary function. Now e is the exponential form, which has the power m1x. Now why do it has a power of m1x? For example, let's see, and let us consider m1 is equals to 2. So the first complementary function would have been c1 e to the power 2x. Yes. Now what is c2, c3? Well, these are complementary function representation. Now we can see over here that at the end, at the right hand side, on the top, or about in the middle, cn is equals to e mn x. I'm talking about case 1. Now over here, if we consider mn to be 15, it would become cn e to the power 15x. Yes, simple is it. Now let us consider case number 2. If the roots of auxiliary equation are real and repeated. Now sorry for the disturbance. Now case number 2. Now case number 2 states that the roots are real and repeated. Now when the roots are repeated, we actually go with a form like this. Now I have considered m3 and m4 equal. Now if this is the case, we would write c3 plus c4x into e power mx. Now if for example there were three roots which would have been equal, we would have write c3 plus c4x plus c5x square. Yes, we would have written x square with it. Now over here you can see that x is increasing with power depending upon how many roots are equal, and then we just multiply it with e power m into x. Simple is it? Now let us consider case number 3. If the roots of auxiliary equation are imaginary. Now over here I have considered m1 and m2 as imaginary roots. Now you can see I have written it in now for case number 3. In case number 3 it states that if the roots of auxiliary equation are imaginary, what would we do? Well, now d I have considered as roots m1 m2 up to mn, where now I have considered m as imaginary root a plus iota b, and m2 the second root has a minus iota b. Now to actually write it in a complementary form, complementary function form, you can see that we just write e power ax. Why do we write e to power ax? We write e power ax because of this letter first. Now here it could be a constant a1 2 3 4 5 up to whatever you take. Now over here it would become e power ax, and then c1 cos bx plus c2 sin bx. Now all of this are the roots of this function, this root m1. Now for a minus iota b, that is root 2. Now over here you can see I have again written e power ax because of this a. I could have if the value of a is 2, we would have written e to the power 2x. Now again c3 cos bx plus c4 sin bx, and then continue onwards. Now over here you could see that we have taken two c functions, that is c3 and c4, just to define root m2, and similarly c1 and c2 to define root m1. So these are the three cases, and this is how you solve a complementary function. Thank you for your time. Allah Hafiz.